Hello, everybody. Welcome to DK Classroom. Today we explain the product description and basic operation of DSF2010 Pro. First, let's introduce the application, function and technical specification of the machine. This machine is designed for charging and discharging characteristic testing of various lithium battery, mn batteries, NiC batteries, lead-acid batteries in the voltage testing, ranging from 2V to 20V. It integrates functions of precision capacity testing, balanced charging and discharging maintenance, automatic data matching, data analysis and comparison, battery temperature monitoring and so on. The isolated channel design can independently charge and discharge the battery in each channel, and can perform balanced charge and discharge of the battery modules in the battery pack, so that the unbalanced battery pack can be restored to a normal balance level. The isolation testing design can determine the location of the defective modules without disassembling the battery pack, then replace it. One single machine has 8 channels and can test 8 battery modules at one time. According to the module number in different battery packs, the corresponding number of single machines can be configured to a testing system to complete the one-go test for the whole battery pack. Take the NIM batteries as an sample. Due to the characteristics of NIM batteries, the testing of the same battery pack needs to be completed in one time to ensure the accuracy of testing. For example, the Toyota 97 Prius battery pack has 40 modules, so you need 5 single machines to complete the one-go test of the battery pack. This machine can be applied to the testing and maintenance of the traction batteries of the main hybrid vehicles on the market. First we introduce the front of the machine. This is the air inlet of the device. Here are the 2 rows of channel indicator lights. This port is connected to the temperature and voltage sampling line. This is the current output port connected to the current output line. This is the address of the device. When multiple devices are connected to the computer, you need to move the address to a different number. This is the data indicator and the network signal indicator. This is the LAN port. This is the switch. This is the power cord. Here is the air outlet. Please leave enough space. Do not block the air outlet. Below we explain the software installation. Open the software installation package. The first step is to select the installation location. Some system does not have an installation location selection, then the default installation is disk D. Do not choose the disk C as the installation location. If you install to the disk C, the work step cannot be added in the next operation. If you install it on the C disk, you need to use the administrator mode to start the software, but for simplicity and convenience, please do not install on the disk C. After selecting the installation location, click Next to start the installation. Launch the software after installation is completed. In the initial running, if your network firewall is turned on normally, then the network selection will come out. Please check the public network to allow the program to pass through the firewall. If this public network is not selected, it may show connecting all the time when connecting to the machine. Then you need to turn off the public network firewall or reset this program to pass the public network firewall. Enter the main interface of the software. The software installation is complete. Below we explain the connection between the machine and the software. Connect the machine and the computer with the network cable. If you have purchased more than one machine, then you can connect through a switch. When more than one machine is connected to one computer, the address at the back must be moved to a different location. If it is a whole set of testing cabinets, the address of the machine has been set before leaving the factory. Then we turn on the machine, and after the initial flashing of the indicator light on the machine, it finally shows that the red lights in upper row are keeping on. Click the Connect button on the software. click the network search button. Normally a device name will appear. Select the device, click the connect and IP selection box will appear. You can directly default without modifying it. If there are more than one machine, the IP cannot be the same, and then click OK. It shows that it is connecting and it will show online in a few seconds. After the device is connected, the device channel information is displayed. When the battery is not connected, and the temperature detection cable is not connected, all data is displayed as 0. The device number is displayed here. Double-click the device number to view some information of the machine. There are 2 temperatures here, and the fan speeds up as the temperature rises. There is a testing cabinet number here. If there are only a few units, then you don't need to change it here after you change the address on the back of the machine. If one computer is connected to multiple inspection cabinets, then enter the corresponding cabinet number here to avoid confusion. Here is the work step setting, matching setting, analysis. These functions will be introduced later. The device model shown here, DK Special software can connect different types of DK series equipment at the same time. The software will automatically identify the connected device. Here you can customize the background color of the work step. Channel information can also be displayed in a list. Below we explain the settings and attentions of the work steps. First, click the step button in the upper left corner of the software. The step setting interface appears. First, select the device model, and create a work program under the corresponding device model. We are now going to use DSF2010 Pro for testing. Choose DSF2010 Pro. Then click New Program on the right to create the working program under this model. Enter a program name. This program name is convenient for query in memory by yourself. If the software was installed on the disk C, it may be abnormal when creating a new program, and needs to start in administrator mode. Right-click the program name can be moved up, or down, renamed or deleted. The left side shows the step under this program. After the work program is established, click to add the corresponding work steps under this program. Here you can see different steps in the drop-down box. You can select the step type according to your needs, fill in the relevant parameters, and click Confirm to create a step. Take the 7.2-volt NIM battery module as an example. The following is a general step sequence for testing nickel metal hydride batteries. The first step, discharge. Constant current discharge is generally used to measure capacity. For the parameters here, cutoff voltage and constant current are essential items. Time and capacity are optional. The discharge will stop when the cutoff voltage is reached, so there is no need to worry about the problem of over-discharge, unless the cutoff voltage is set wrong. The discharge cutoff voltage of a single nickel metal hydride cell is 1 volt. The 7.2 volts NiMH battery module is composed of 6 cells. The cutoff voltage is 6 volts. 9.6 volts NiMH battery module is composed of 8 cells. The cutoff voltage is 8 volts. The 14.4 volts NiMH battery module is composed of 12 cells. The cutoff voltage is 12 volts. What we are testing is the 72V NIM battery module now. Fill in 6000 here. Next, set the discharge current. The best discharge current of NiMH battery is 01C, 05C. C means the rated capacity of the battery. If the battery capacity is 6000 mAh, we set 600 to 3000 mA here. The capacity and time cannot be filled in. If you want to fill in the value, do not fill in the value lower than the actual value. Otherwise, the discharge will end in advance, resulting in inaccurate capacity measurement. When filling in the capacity, fill in the rated capacity of the battery. The rated capacity of the battery we are testing is 6000 mAh. Enter 6000 here. The time is calculated by dividing the rated capacity by the discharging current. The 6000 mAh battery is discharged with 3000 mA current. The time is 120 minutes. Fill in 120 here. Click Confirm. The discharge step setting is completed. After discharging or charging, if you want to carry out the next work step, then set up a idle work step between discharging and charging. Idle means stopping for a few minutes. The function of idle is relatively important. First, to add the idle step after the charging or discharging, the final test result can get an internal resistance value. We will talk about this later in the data analysis. Second, the idle allows the battery voltage and temperature to return to normal values, making the test results more accurate. Third, to avoid battery damage caused by sudden conversion of battery charging and discharging, it also reduces the internal temperature of the machine and reduces the failure rate of the machine. The idle time is generally not less than 5 minutes. Second step, charging. mn.H batteries are charged in constant current methods. The parameters here: time, highest charge voltage, max V, constant current, conc, capacity, negative voltage increment, V, temperature rise rate. The highest charge voltage and constant current must be set. Other conditions can be set selectively. Here we provide multiple charging stop conditions to ensure safe and accurate charging. First, set the highest charging voltage. The highest charging voltage of a NIM single cell is 1.45 V. The 72V mn.H battery module is composed of 6 cells connected in series. The highest charging voltage is 87 V. The battery we are currently testing is a 72V mn.H battery module. Here we enter 8700. The 96V mn.H battery module is composed of 8 cells connected in series. The highest charging voltage is 116V. The 144V mn.H battery module is composed of 12 cells connected in series. The highest charging voltage is 174V. Next we set the charging current. The charging method of mn.H battery can be divided into standard charging, speed-up charging, and fast charging according to the charging current. The standard charging current is 0.1 C. If it is a 6000 mAh battery, the standard charging current is 600 mA. The speed-up charging current is 0.3 C. If it is a 6000 mAh battery, the speed-up charging current is 1800 mA. The fast charging current is 0.5 C. If it is a 6000 mAh battery, the fast charging current is 3000 mA. Below we set the speed-up charging current, 6000 mAh. Here, we enter 1800 mA. As per the different testing needs, here you can set different current values, according to the above charging method. Negative voltage increment means voltage drop after the battery reaches the highest charging voltage. Since the mn.H battery takes a long time to appear negative voltage increment, we set this value to be small here, to increase the sensitivity of stopping charging and avoid overcharging. At the same time, there is a temperature rise rate here. The temperature rise rate refers to the temperature rise of the battery within 1 minute. When the battery temperature rises to this value within 1 minute, the charging stops. Here we set it to 1, which means that if the temperature rises 1 degree Celsius in 1 minute, the charging stops automatically. Time and capacity cannot be filled. If you want to fill not lower than the actual value. Otherwise the charge will end prematurely. Capacity: set the rated capacity of the battery. The time is calculated by dividing the capacity by the charging current. There is also a temperature here, which means that, when the battery reaches this temperature, charging stops automatically. You can do it without setting it, or set it according to your needs. If you do not need to monitor the battery temperature, don't need to set the temperature. If the temperature is 0, it means the temperature is not set. After all the parameters are set, click Confirm, and the charging step setting is completed. After charging, if you want to carry out a work step, then also need to add an idle work step. Third step, cycle. Cycle means that the system automatically recharges and discharges the battery, and the cycle is helpful to activate the battery and restore the battery capacity. There are 2 parameters. The initial parameters are all 0, and many users only change the cycle times, but the switch step number is not set. Then it will happen the step cannot be switched. This switch step is the sequence number at front of the step. You can fill in the sequence number of the step you want to switch to. For example, after charging, we need to switch to the first working step, discharge, and cycle for 2 times. Then fill 1 in the switch step, and 2 in the cycles. If the last step is a cycle step, it is best to add a stop step after the cycle step. If you don't edit, the software will execute the stop step by default, but it is best to add it manually to stop working, avoid possible accidents. Selecting the step, the up and down buttons can move the sequence of the step. The edit button can edit the step setting. The delete button can delete the step. After all the steps have been set up, this save data must be checked, and then at least one of the following conditions needs to be checked. Check the time, fill in 10 seconds, not too short. Of course, it is also possible to check the voltage and current, fill in the interval. This interval is to import a piece of data into the analysis according to the current or voltage change value. Finally, click Save. A new step program has been set. The import and export buttons in the below can import or export work program settings. Next, we set the 9.6V and 14.4V NiMH battery work program according to the previous setting method. During charging, using a high power fan to cool the battery will help the battery stay in the best charging condition. Matching means that the system automatically filters the tested batteries according to the user's set standards, and automatically identifies the channels that meet or do not meet. Click on the match in the upper left corner to open the matching setting interface. First, we set up a new matching program, and fill in a name. We can add conditions under the program. The condition types include time, capacity, and voltage. Here we can add one condition or multiple conditions, but only one condition can be added at a time. Do not add 2 or 3 conditions at the same time. Then fill in the data. Take this step as an example. If you need to filter the capacity of the last discharge cycle, then the corresponding cycle number is 2. The step sequence number of discharge is 1. Then in the step number fill in the corresponding step sequence number. Then fill in the capacity range in the below. There is no standard for this value, users may set it according to their own requirements. Click Confirm, a matching condition is set. Here you can also set the flashing mode of the channel light. Here we can also add the voltage that has been idled after the last charge cycle as a condition. The last cycle number is 2. And the step sequence number of idle after the charge is 4. Fill in the voltage range. Click Save. The matching program setting is complete. Connect the device with the output wire delivered with the package. This is the temperature sensor. This is the clip that connects the positive and negative poles of the battery. The red connects to the positive pole, and the black connects to the negative pole. Connect the output wires to the output ports of the device. The voltage detection line and the temperature detection line are the same port. When connecting, be careful to align it with the groove and then push it in. Then the red clip connects to the positive pole, and the black clip connects to the negative pole. At the same time, put the temperature sensor into the battery temperature detection hole. After the battery is connected, the channel information will display the actual voltage of the current battery, and the channel connected to the temperature detection line will display the actual temperature. If you select channel 1 and press Shift, and then select 9, all channels 1-9 will be selected. Press Ctrl+A to select all. Then right-click to Settings/Start, select the corresponding program name, and click Confirm to start the program. Please pay attention to whether the automatic standby of the computer is turned on. If it is turned on, please turn off the automatic standby. When the computer is in standby mode, the software will not be able to receive data from the device. Check whether each channel has a current value display. If there is no current value, please check whether the two sides of the clip are in good contact with the battery. If the contact is good, please replace the testing cable to see if there is a problem with the cable. Right-click on the information to view the information of the current channel and the running work program. If you leave during the test and worries about an accident, you can click the pause button when leaving and click the continue button to continue the test after coming back. This continue is not allowed to use unless the stop by manual button or warning state of clamp disconnection. Except the above two cases, click continue button, the machine will run the discharge at wrong current. After starting the work program normally, wait for the work program to complete. Next, we explain the viewing and data analysis of test results. After all work steps are completed, if the matching program has been set, then we select all and right-click to select the set matching program. If the channel comply with conditions set, it will be marked tick, and if the conditions are not met, it will be marked cross. At the same time, there is also an matching result here. The filter conditions and the corresponding values of each channel can be viewed. We can click to export the test data, enter file name, export this data and save it in an Excel file. Open the matching report to view the detailed data. In the matching report, the inconsistent data is marked in red. Right-click to cancel the match. Select a channel and right-click Analysis to view the testing data of this channel. The capacity check should be based on the discharged capacity after fully charged, not based on the charged capacity. Click the plus sign to expand the data, and you can view each data under this work step. Click here to view the internal resistance value tested. This value is not an accurate value, it is only for consistency comparison between each other. The principle of our capacity tester is different from that of the internal resistance meter. To get the actual internal resistance value, you should use a professional internal resistance meter. Click Export here can export data, but the data exported from here is all the data sent by the device. Too much data is not easy to view. So don't mind exporting the test report from here. Need to export the test report to save. We generally right-click on the channel to export the report, and save it in Excel format. You may also select multiple channels for consistency analysis and comparison. You can compare the consistency of the batteries. If a curve is found to be very different, we can find which channel's curve is by checking and unchecking channels. We can also select multiple channels to export the testing data and save. Click the Analysis button on the main interface to view historical data. Click to import the data file to be analyzed. Click the corresponding model to enter the data folder. The file name here, 011, 012, 027 corresponds to the channel of each device. 027 means the 7th channel of number 0 cabinet number 2 device. The data file of 011, 012, 027 is the latest test record of the channel. If the channel performs a new test, the original data will be saved in the name as 027 plus time. Like this file name, it represents the data of number 0 cabinet number 2 device number 7 channel started at 40 minutes and 40 seconds on September 15, 2021. Select the channel name file to import the latest testing record for viewing and analysis. Select the historical file to import the historical testing record for viewing and analysis. The above is the operation and setting of DSF2010 Pro testing NiMH battery module. If you need to test other types of batteries, such as lithium batteries, its charging methods and parameter settings are different from NiMH batteries, please feel free to contact us for technical support. Thank you for watching.
DK